Welcome. Thank you for joining us on at least what is in Brisbane an incredibly rainy afternoon. My name is Ryan Palfrey. I'm a senior product manager here at Emesent, responsible for the geospatial line of our business, and I'm joined today by Alistair. Would you like to introduce yourself, Alistair?
Oh, sure. My name's Alistair. I'm the founder and CEO of Mangoesmapping, which is the Australian, New Zealand and Pacific distributor for Emlid RTK GNSS, amongst many other things.
Awesome. And we're here today, to take you through, as the title suggests, smarter field accuracy, Emesent Hovermap Emlid GNSS, a combo approach from two great companies. So I'll just, before we go any further, set some ground rules. So we're recording this session. You can enter your questions at any time. They'll come through to us. And then at the end of the webinar, we'll circle back to those, and Alistair and I will do our best to talk to you about them. You'll be muted, and you can change your view using the active cameras tab, focusing on either my face or preferably the slide deck. So I'll be taking you through just the first little bit, a bit of background about Emesent, about Hovermap, the sorts of things that we do, conscious there's a varying degree of familiarity potentially in the audience. I'll then take you through RTK, the thing we're all here to discuss, what that looks like for us, what it means for our clients. And then I'll hand over to Alistair, who'll give you the rundown on all things Emlid, and then we'll finish off with a couple of summary slides talking about the accuracy and all the reporting we do about that. And then, plenty of time at the end for any questions. So let's crack on. Starting at the start with Emesent's story. Emesent started life as a autonomous drone company several years ago, spinning out a CSIRO. And this on the screen here is the Hovermap STX, which is our flagship scanner. And it's a device that has evolved in time to do an enormous amount of things across a load of interesting industries, focusing mining, focusing geospatial, AEC, oil and gas, defense, forestry, you name it. The Hovermap has been pretty much everywhere. And the reason for that is that Hovermap is such an accurate, reliable, and versatile scanner. So on the back there, you can see it's got a little slot. That slot goes into all manner of accessories, and we'll go into some of those in a little while. What that means is that folks are using it all over the world in all different types of environments. So as I've got on the screen there, in handheld, on a drone, vehicle or pole, lowered into a cage, mounted to a backpack. And Emesent's Hovermap also has autonomous functionality for users who are trying to access really challenging areas, attaching to a drone, an M350 or a free-fly Astro, and exploring some really dark and dangerous places where humans can't go. But in terms of where we are above ground, or at least that's where I like to spend my time, what we're mostly trying to do is create awesome digital twins of assets 10 times quicker than you could in the past, and making impossible captures possible. So Emesent and the Hovermap was one of the cornerstone pieces of technology, creating the most complete digital twin of Alcatraz, working with Pete Kelsey from VCTO Labs, along with a whole heap of other technology providers to take the island of Alcatraz, the prison, the history, and to create that in a historical preservation sort of way. And just this is where we see SLAM is seeing so much uptake. SLAM's really having its moment, and it's all about that speed to capture. Some captures were just previously impossible with the time you had, and SLAM really changes all of that. And the Hovermap, the thing that we spend the most of our time thinking about for surveyors and for reality capture professionals is accuracy, and in particular RTK SLAM accuracy, which is something that's really, really exciting, and I'll dig into in more depth in a little while. But as I mentioned, Emesent started life doing drone autonomy. And so the SLAM algorithm, which we use, what it does is it works backwards from the environment. So it uses the LiDAR on the Hovermap, triangulates that data with the IMU within the scanner, in addition to RTK when it exists, to identify the position of the scanner in the environment in real time. And that's what allows a mobile SLAM scanner to go through the environment very quickly, whereas tripod scanners need to be still. And because we have that autonomous heritage, when you're trying to use that technology to fly drones, you've got to make your algorithm pretty robust, because if it's not robust, the drone will ultimately crash. And unfortunately, crash they did quite a bit in the early days until the technology was refined. And so from every crash, Emesent learned now there are tens of thousands of autonomous flight hours on this SLAM. And that same SLAM is what we use to power our above ground work as well. And so we work with our surveyor clients to understand and validate the accuracy. On the GCP side, we're getting between 10 to 15 millimeters 3D. RTK, as we know, can vary considerably depending on the environment, but in good conditions between 15 and 35. Solid local accuracy for getting those measurements great, and then precision, something we're looking to improve, but nice, neat, clean point clouds. More on that in future releases of our software. And that same autonomous heritage also creates unmatched reliability. So many of you will have heard about SLAM scanners. If you're what I call SLAM curious, you'll have heard about this concept of SLAM drift. You know, SLAM is a black box which takes all this LiDAR data and tries to, run these algorithms and figure out where it is. But in that black box is this estimation error, and that's what you will have heard as SLAM drift. So a lot of what we do here at Emesent is thinking about what are the ways that we can augment or improve the SLAM algorithm to reduce that drift, make the result more predictable, make it more reliable, even in the most challenging SLAM environments. So outdoors in wide open spaces is a clear example of one of those areas. And that's something we've been spending a lot of time working on with RTK to use the two data sources to be more reliable. And we're trusted by some of the biggest companies in the world to do SLAM mapping. NASA being our favorite one to put on the PowerPoint slide, of course, but many other awesome companies as well, from progress tracking to topo survey to as-builts to doing tunnel mapping in those really challenging SLAM environments, underground in mines, above ground in open pit. It really is, where can mobile mapping take you, particularly in 2025 as the technology is maturing and the workflows are becoming more seamless. And so where does that leave us in terms of RTK? Well, a couple of years ago, we were listening to our users and they were telling us we want to georeference really easily. That was the key need. Using control was quite painful. They want to georeference easily, but also outdoors, as I mentioned, SLAM can drift. Because SLAM is working backwards from the environment around it, using the LiDAR points to triangulate itself, if there aren't many things around, what we call SLAM features, then SLAM doesn't necessarily do a very good job. So in comes RTK. And what we've done is build out an accessory suite where the same scanner uses different accessories depending on the type of job that you have. You can fly it, you can drive it, you can walk it. And again, the same RTK, which delivers that georeferencing and drift correction. And of course, on the screen there, you can see our favorite, the Emlid. So why is RTK useful for these sorts of scanners? And the first reason that we dug into was with our users was that, a lot of the time you can use ground control to georeference, but sometimes you don't always need to. It can be painful, it can be manual, there can be environments where it's really challenging, and maybe you just need, 20 millimeters rather than 5 to 10. And particularly over large areas, large distances, I was speaking to one of our users this morning who does power line mapping, 10 kilometers at a time. Over a certain distance, do you really want to get the total station out? Not everyone does. And as I mentioned, those large areas can be difficult for SLAM. Drift decreases the scan accuracy in certain environments. One other thing I would raise as well is, georeferencing indoors can be painful. Now, I'm no surveyor, but I do try and get the total station out occasionally, and traversing control indoors can be really quite tricky, at least with all the folks I have in the office next to me. The ability to combine RTK and SLAM together allows you to do indoor-outdoor georeferencing. So starting with RTK outside the building, using that as kind of an anchor point, and then letting SLAM take over where the RTK data is either compromised, maybe it's a float or not very accurate, or you're indoors. And so by balancing the two data sources, you can kind of get the best of both worlds. And we see lots of folks using that, what we call mixed GPS or indoor-outdoor use case, combining the best of RTK and the best of SLAM together. And we're seeing some really great results. So one of our clients, Gary from GeoTwin down in Sydney, he needed to do a topographic survey and tree survey and a CAD model of a 2-kilometer stretch of road down in Sydney. And there was a lot of challenging environments here. So there was a thick bush down the side, lots of trees and grass. So he couldn't just fly over with drone photogrammetry. There was a little culvert underneath the roads, and he didn't have the time, and I assume the client didn't have the budget to close the road for roadworks. And so he used the single scanner, the Hovermap STX, with the plethora of accessories that allowed him to access those different environments. So he drove the road with RTK, he put it on the drone to get the coverage on the tops of the trees, he put it on the backpack to go through the forest where he needed more coverage, and then the extension pole to get over, certain parts of the environment where he needed to get down. I think it was under the culvert as well. And it took him only a day of capture versus, what he estimated would have been 3 weeks with a total station to get all of the different bits of information that he needed. And of course, as well, the additional benefit is, you get a nice pretty picture at the end. You get a nice deliverable to show your client with the images, that 3D context. And if you're particularly big on LinkedIn, maybe you chuck it in Nubigon and do a cool animation as well. And so I've just got on screen here a quick fly through of this Mount Cootha up in Brisbane. This is from our vehicle RTK. And so with the 360 colorization we have on it as well, you can essentially get the full picture together. It's the color, it's the images, it's the georeference point cloud all in one. We recommend with the vehicle, it's about 40 kilometers an hour is as fast as you want to drive to get the right density. But it's not just using it on one. What our users find most useful is the combo approach, because it's very rare that you have a job that you can just do with one piece of kit. It's driving it and then filling it in with the backpack, or it's using the backpack and then flying the top of the building, all sorts of things like that. So that's a high-level overview of the Emesent ecosystem. There's a lot more to go into, of course, but I'll pause there and I'll pass you over to Alistair, who will tell you a little bit more about Emlid.
Thanks, Ryan. And just want to make a comment. That's a really lovely point cloud data set. It's nice and dense. Gary Alali from GeoTwin, whose case study you used there, is also a big fan of the Emlid gear and uses that across GeoTwin and the other company that he works with, Road and Civil Surveys. And we might touch back on that later, but I thought perhaps I could start by introducing the audience, the viewers, to perhaps our history with Emlid RTK. So Mangoesmapping has been working with Emlid hardware since they released their very first RTK receiver back in 2017. At the time, I was doing some pro bono environmental work. Mangoesmapping was basically a startup, and we needed to insert ground control for photogrammetry surveys using the trusty old Phantom 3 Pro drones. And as a startup, we were looking at the sort of higher end solutions and challenged by the acquisition costs of those. And these guys were taking pre-orders at the time for their very first RTK to get the money they needed to build it. And so I pre-ordered some. It cost me, really negligible amounts compared to the major solutions. I think I was quoted 58,000 for a base rover pair, and I took a punt on these, and it was at the time for these single phase GNSS RTKs only about $800 each. And I was like, well, if they work, they work, and I've saved a stack of money. And if they don't work, well, I can afford to just pop them on the shelf and move on. And it took about 4 months for these guys to show up. And when they did, I took them home, I configured them. I took the one that I'd configured as a base, stuck it on a benchmark down the road and around the corner from home at 1 a.m., super enthusiastic, and then went to another benchmark further down the road, and I was within 7 mil. And I just couldn't believe that these single phase GNSS receivers could be that tight. And within a week, I got back to Emlid and made it really clear to them how disruptive I saw this technology as, and how much I enjoyed the simplicity of it, and how much I wanted to be able to be a part of bringing this to the Australian, New Zealand and oceanic market. And so that's one of the things that we've been doing over the last 8 years. So if you want to just move to the next slide, please, Ryan. This is an image of a point cloud of one of the erosion gullies that we created using the Phantom 3 Pro and coordinated with the RTK. And the reason that we needed the RTK was that we were looking at longitudinal monitoring of these erosion gullies, and looking at quantifying the efficacy, the effectiveness of different experimental interventions to try and limit the contribution of sediment to the Great Barrier Reef lagoon here in Australia. So we wanted to improve water quality on the reef, improve the long-term outlook for the reef, and to do that we needed to do long-term observations over these erosion gullies spanning many years, and we needed stable, precise and reliable control to overlay these 3D models on each other. If you could go to the next slide, please, Ryan. Thank you. So, we used it. It was great. We ended up winning an Asia Pacific Environment and Sustainability Award for our work, determining more, the relative efficacy of these different experimental interventions to contribute to environmental management. And as I said, we got involved in bringing this stuff to Australia. And by 2019, when Emlid released the Reach RS2, which was a multi-band receiver that is incredibly capable and still very affordable, we were starting to sell hundreds of these receivers into the Australian market. And I thought, I'm really putting my name behind this. And I know that I have my own, understanding of how this performs against benchmarks, but I now want to understand how it performs against our competing hardware. So I bought some Leica GNSS hardware at the time, and I did a fairly rough and ready test, connecting each receiver on the same mark to a local AusCores base, and just compared the horizontal and vertical observations between our receiver, which is about a 20th of the cost at the time, to the Leica GS12 that we used in comparison. And as you can see, the horizontal observations were within a millimeter, which was unusually tight, and the vertical observations between all of the instruments varied within a range of under 10 mil, which gave me the confidence to really continue to invest in marketing and presenting this product to Australia. Let's go to the next slide. Thanks, Ryan. So after COVID, we took it to the next level, and we engaged an independent survey firm to do their own analysis of the relative performance of Emlid versus Trimble. And if you're interested in the full story, the information, including all of the tables that compares the relative horizontal and vertical conformance of Emlid and Trimble's hardware, is available for download from the news section of the Map Gear website, which is another one of our group of companies. But it's this sort of independent, external hands-off survey validation that gives us the confidence to, present our Emlid hardware as a competing product that really can take it to the big guys in terms of precision and reliability. And I think it's probably got one over them in terms of simplicity and the relative intuitiveness of the user interface. And of course, our 16-hour internal battery simplifies life for people in the field a bit too. Thank you, Ryan. So a great example of someone that relies on Emlid to do professional work is cadastral surveyor Dale Atkinson from Atkinson and Boy in Townsville. And Dale uses Emlid as part of his hybrid fleet for doing cadastral surveys to reinstate property boundaries for rural, pastoral to freehold conversions here in Queensland. And he loves the fact that these are lightweight, compact and portable. And it's very easy for him to pop this under his arm, pop a tripod over his shoulder, and hike 700 meters from wherever the chopper can drop him down between the trees up to the high point that he wants to do his static observations. And I believe that Queensland Transport and Main Roads are also using our hardware for their static observations now too, in a couple of different regions in Queensland. Thanks, Ryan. So earlier I referred to the intuitive user interface of the Emlid software, and I think this is particularly relevant for users of Emesent's Hovermap STX hardware, because when you're configuring the GNSS receiver, it's just so incredibly easy. You use your mobile phone as a controller. You can do full survey functions using your phone, including, transverse, traverse, and sophisticated survey functions, you can also configure the device. You can import DXF hardware, but it's all very intuitive and easy to use. And I think, you know, one of the things about Emlid is that they really focus on user experience and design as a priority. And a great example of that is that they embedded tilt compensation hardware into the Reach RS2, but they never released that as a feature for customers to work with because they didn't like the user experience. And they waited until they were able to master that with the RS3, which was like, you know, 4 years later before they exposed that to customers. So, you know, they're very focused on simple, intuitive user experiences. They've got a fantastic reputation as being responsive. Their gear is reliable, lightweight, easy to use. And they've taken it one step further by recently launching a new range of products, right? So at Intergeo just a few weeks ago, where Ryan and I also caught up for a quick chat, Emlid launched their next generation Emlid RTK GNSS receivers, all of which contain tilt compensation, and the Reach RS4 Pro takes it to a whole new level with machine vision cameras that allow you to do augmented reality set out and photogrammetry pickup for those hard to reach areas when you are doing GNSS RTK surveys and not just integrating it into the Hovermap technology solution. So if we just take a closer look at the photogrammetry pickup, you can see using that forward-facing camera, you activate the photo mapping or photo measurement, and it collects a series of frames as you walk past the obscured item that you can't collect with GNSS, and then it presents you with those frames, and you can just annotate the object that you want coordinates for in one frame, and it will then show you that annotated on a bunch of other frames, so you can confirm that you've got the right object and you get your coordinates. And that's, people have asked, you know, what sort of accuracy can we expect out of that? And we basically say that with the IMU inside the unit and the RTK GNSS, that you can maintain those sort of RTK GNSS reliability out to 10 to 15 meters. I think beyond that, it starts to get a little looser. But certainly within that 10 to 15 meter range, you can rely on that solution to give you a good position, a good coordinate for your point. And now I'll just show you a very brief 5-second video that gives you a taste of that augmented reality stakeout. So you can see using the forward-facing camera, it shows you the location of the thing that you're staking out. And as you get closer, it moves to a digital bubble overlaid on the downward-facing camera that shows you the point that you're trying to locate. I guess that helps to give people a little understanding of the Emlid hardware, Ryan. I know that, you know, these are very popular with your customers, that we see Emesent selling a lot of RTK solutions with Emlid, and independently of Hovermap, we are seeing, you know, many hundreds of these receivers being sold across Australia every year. We've got, you know, mining multinationals, state governments, multiple departments in the federal government using it, including notably the Australian Antarctic Division, that are even using the Reach RS hardware for construction set out and biology surveys in Antarctica. I think that's enough, Ryan, to give people a bit of a taste of Emlid. Thank you very much, but I'll certainly hang around and be happy to answer any questions specific to that as we reach the end of the webinar.
Yeah, awesome. No, I would totally echo your comments about the user experience. I mean, we have, yeah, as you've mentioned, many Hovermap users using Emlid as part of the RTK suite. And, you know, as the Hovermap, we have to get them to do a few configurations so that the data comes in the right way that we can ingest it into SLAM. And so that's, you know, so we're sort of responsible for helping them through that. And it's quite easy to do that because the Emlid Flow app is really simple. I was just taking a couple of my colleagues through our RTK solution just the other day for the first time, and the Emlid Flow setup was yeah, pretty much effortless, and one of the key benefits that our users talk to, definitely.
Yeah, actually, if I can just expand on that just briefly, we talked earlier about Gary Alali and GeoTwin, and the other company, Road and Civil Surveys, has many surveyors working across, you know, the broader Sydney region and beyond. And Emlid have this really unique Emlid Flow 360 capability. So as you're collecting data in the field, if you're logged into an Emlid account, it actually synchronizes that online. And what that means is that survey managers can set up a job, upload the project, and it just appears on your phone, and they're able to take jobs and send surveyors directly from one site to another site without any preparation or having to come back to the office to load up the controller with the new project, which is delivering productivity dividends and the capacity to deliver, really high levels of service. And that's quite novel from what I understand.
Yeah, I think it's about the confidence. So much of what we hear from our users is, being confident in the data in the field. I think the RTK really helps with that, particularly with SLAM being quite uncertain. RTK and Emlid providing all that, real-time, precision. How's it all going? You can get confident. Okay, even if SLAM isn't where I think it's going to be, the RTK has got my back, so to speak.
Yeah, and actually for the survey managers that may be watching, Emlid gave some hints at InterGeo of what they're planning to release, which is effectively a business version of Emlid Flow that allows, multiple levels of access and like a one-to-many relationship between, or many-to-many relationship between projects, users, managers, different levels of permissions. So you can have guys go out in the field and stake stuff out and not have to have any permissions to edit the hardware. You can have the manager in the office see where each surveyor is on the site and in real time look at the quality of the data that they're collecting, and even, give them a quick call and say, hey, you got to go back and pick that point up again, because while you're there, I can see that that's not quite right. So that is some really interesting capability that we're expecting Emlid to formally announce in the next month or two.
Awesome. No, I think Emesent ourselves will need a business subscription to that with all of our use worldwide. Awesome. Well, just a couple more slides to go through to sort of wrap up, I suppose, the Emesent Mangoesmapping Emlid story. One of the things I was thinking about as you were talking, Alistair, is you and I have both said the word like accuracy a fair few times throughout. Like it's just one of those things that continues to be important. And in particular, when you put these data sources together, what does it mean? Right, we've got SLAM and its sort of accuracy that I spoke about towards the start, with the black boxness of it, and sometimes that concept of drift. We've got RTK, which has a pretty well-known or well-understood accuracy and the things that impact that. What happens when you put them together? And there's a couple of aspects to this. The first is we're conscious that as a manufacturer, we're always going to be biased towards publishing the best data, but we also want to be realistic. Like we're setting expectations for our clients, many who have accuracy requirements on their projects. And so if we're setting unrealistic expectations, we're setting them up to fail. So the accuracy approach that we took is to get independent third parties to validate it for us, because that is, we still have to ask them for their help, but that's the way that we could try and provide that kind of independent, authoritative voice about the accuracy results. And the second thing to touch on is, under the hood, a lot of what we're doing with the two data sources is trying to weight the uncertainties of them to make them better. And what we've learned typically is they improve each other. So that's good. The combination of the two is often beneficial. And so we engaged Orion Spatial Solutions, a company and a client of ours in Australia and Brisbane. And in Wacol, which is where our production facility is located, they surveyed a 2-kilometer stretch of road. On the right-hand side there, you can see the picture with all the stations all the way along, in accordance with TMR survey standards. And they had QA stations and control stations alternating every 150 meters using, the best kit, that you can essentially get. 1 second TS13 total station, digital leveling it as well, static observations where needed, and all the business that comes with all of that. And so they set up that control network. We conducted the scan with the vehicle RTK solution, so sticking the Hovermap with the Emlid, linking the two together, getting it a fix, driving up and down a couple of times, and then the same with the backpack with the Emlid, the same piece of kit, just a different configuration. And while we were going, we were in our Commander application, which is our app which interfaces with Hovermap and gives you that real-time view of what's going on. We were watching the RTK status. So one of the great things about the Emlid as a manufacturer, as an integrator, is they allow a lot of data to be passed from the Emlid through to a third-party piece of kit. So we can take the precision, the number of satellites, the confidence, and pipe that through into our Commander app. So once they finish configuring in the Emlid Flow app, users can then monitor the progress of the scan and how Hovermap is reacting to the RTK in real time. So we went up and back with both the backpack and the vehicle. We then processed the data in our software Aura, and then we passed it off to Orion Spatial to do the accuracy validation and create a report. And so these are the results that they gave us. You can Google Emesent Backpack RTK Accuracy Report to go onto our website and just put in your name and email address, and you can download it. It's the full business with an overview. Here's the data, and here is every single point. I think there are about 75 points across the 2 kilometer stretch of road, which are picked, and all the individual XYZ accuracies and diffs between the total station and the RTK. And so on the backpack, we got an awesome horizontal accuracy of 14 millimeters, vertical of 5, and then vehicle going a bit faster, of course, 30 millimeters horizontal and 16 millimeters vertical. And what's so interesting about that, and to my point about balancing the 2 data sources of RTK and SLAM, is that what we've learned is that for reasons no one really truly knows the answer to yet on a deep level, RTK and SLAM increases the vertical accuracy, reduces the vertical uncertainty. There's some hypotheses floating around inside Emesent as to why that's the case. One key point is that as you're going along, if you're on the backpack, you're essentially walking along at a single height for quite a while, and then SLAM helps to pull in the vertical there. You've got the road surface beneath you. It provides something that brings down the vertical. But we're still doing a lot of experimentation to learn more and just to figure out how do we combine these 2 data sources the best. One of the things I'm thinking about and I'm talking to our users about is what happens if we can add ground control to this as well? How much better is possible in terms of doing it on those really high accuracy road jobs? Because I think that's a really exciting area for us to explore. On the right-hand side there, you can see an RTK accuracy report. That's not the report that's on our website. The one on the website looks much more schmick and is much more official. This is the accuracy report that our users see when they process the data in our software. So we take the data from the Emlid about the RTK quality over the course of the scan, and we then report that back to the user so they can understand the RTK quality that they had during the scan and then what they can expect in terms of overall accuracy. But that, of course, that's not the same as validating it against control, which our users often do. We also publish at the bottom there the RTK SLAM distance, and this is where we take the 2 data sources and we figure out what's the difference between them. And this allows the user to diagnose if there's been a lot of drift in the SLAM that the RTK has corrected. Where are these 2 data sources converging, or are they on the same page most of the time, or are they quite different? And that's sort of, with the uncertainties in the environment and in the satellites, that's something we want to make sure our users have lots of visibility over, because we hear a lot, it's not about being accurate, it's about being validated accurate. You've got to prove it, to your client or to your boss or whoever else that you're getting the accuracies you need. So we're spending a lot of time at the moment thinking about that piece, making it as accurate as possible, reliably accurate, and then validatedly, that's not a very good word, confidently accurate. And of course, confidently includes the ability to report and interrogate and tweak. So that's the journey we've been on with our users over the last couple of years, and it's a journey we're definitely going to continue. I think that's all for me on the formal slides there. Thank you all for listening to us there. We probably will spend some time looking now at the questions. I'll just switch back to my other screen and check what they've got for us, Alistair. We've got from Andy Chambers, have you explored options for supporting RTK accuracy in remote regions where there is no OSCORs? And the answer to that is yes, we are currently exploring whether we can do PPK. As an alternative, we hear lots of our users are in those sort of challenging environments without mobile phone signal. We want to make sure they're supported. We do have some users who are particularly innovative. They're using Starlink, or they do a long static observation, set up a local base, and then go from there. But we appreciate that that's a little bit of extra overhead. If you have to be in and out, time on site is limited. And yeah, so that's where PPK is something we're looking into. all good. I think that's all the questions there. So if nothing else comes through, I will leave it there. Thank you everyone so much for your time and for checking in, learning a little bit about Emesent and about Emlid. Thank you, of course, Alistair, to Mangoesmapping for coming along and giving us a great rundown.
You're welcome, Ryan. Actually, if I may just comment on that previous question, I don't think it'll provide an answer in terms of the dynamic nature of RTK surveys in remote areas, and PPK certainly makes a lot of sense in that context. And as a company that's based in the deep north of Queensland, you know, we are often out beyond areas of, you know, mobile network and all of that sort of stuff, and most of our drone surveys and other surveys rely on PPK, and we have a great experience with that. But the new generation Emlid hardware that I referred to earlier is all capable of receiving L-band corrections. So we expect that, you know, when u-blox release their own PPP service around the end of Q1 next year, and when Galileo's high accuracy service is also available, that we'll start to see those benefits accrue to users of the new generation Emlid hardware. Thanks, mate.
That'd be fantastic. All right, we'll leave it there. Have a lovely afternoon. If you want to learn more, please reach out to myself or to Alistair or any others. And yeah, have a lovely afternoon.
Thanks, Ryan. Thanks, everyone. Bye.
Thanks all.